Hi folks, this time we're going to talk about electric current. And electric current is electricity that is moving through some sort of a conductor. And it is this motion of electric charge that actually will transport energy from place to place. And because of that law of conservation of energy, the energy of the electrons, or the charge, can be transformed into sound, into motion, into heat, and into light. So electric current is that electricity in motion, and we can use it to do all sorts of wonderful things with electricity. There are two basic types of electricity: DC, or direct current, and AC, or alternating current. Now, DC, or direct current, is the kind of current that you're going to get out of a battery or a power supply that you are going to use with an electronic device, like a cell phone or a laptop or an iPad, something like that. AC, or alternating current, is what is typically going to come out of a wall socket. So we're going to spend a few minutes talking about the two different kinds, how are they different, and why we have those two different kinds. Direct current is a consistent flow of charge that travels in one direction. It's typically produced by a electrochemical cell, like a battery, and it's a steady charge over time. So if this is a graph of voltage versus time, for a typical AA battery, AAA battery, something like that, 1.5 volts, as time goes on, you're going to have a very steady and consistent amount of electrical potential or voltage as time goes on. That is direct current. The current always flows in one direction. It's nice and uniform and nice and steady. Not all devices use DC or AC. They're very, very different kinds of current, and they can be used in different places. DC current is typically used by electronics or computer chips. So you're going to use DC current any place that will be battery powered or can be battery powered. Your cell phone, your laptop, anything that's got a rechargeable battery, or anything that takes a electrochemical battery or cell. So these things are all going to run on DC power. If you have a device and it has a power supply, that power supply is also called a rectifier. A rectifier is an object or a device that conforms the AC power that comes out of the wall socket and can transform that into the DC current that is needed by electronic devices. Now, alternating current is produced in a different way by power stations, and that alternating current flows more like a wave pattern. Alternating current actually alternates. The electricity moves in a wave, first one direction and then another, and one direction and another. And in the same way that a water wave going through the ocean can move energy across the surface of the water, and you know the energy can be moved because if you have ever stood on the shore of a lake and a big wave hits you, you know that you just got hit by something very energetic. Well, an electricity wave can also transport an awful lot of energy. So the electricity energy can be transformed in this wave type method that's called alternating current. The electricity that comes out of the walls in the United States has a voltage, an electrical potential of 120 volts, and it oscillates back and forth 60 times per second. That's why it says 60 hertz, and AC stands for alternating current. Now, totally different kinds of devices use AC from DC. Appliances that rotate, anything that has a rotational motion in it, from fans to blenders to drills, if it's a plug-in drill, those things all are really, really happy with alternating current. Appliances that produce an awful lot of heat, toasters, ovens, water heaters, things like that, very happy with alternating current. Appliances like light bulbs also, the old-fashioned incandescents, they're happy with alternating current. But appliances that are electronic, you have to transform the alternating back into direct current, and that's why you have these rectifiers or power supplies. And I like this picture because it shows you the input is 120 volts AC, 60 hertz. That's the amount of electricity coming out of the wall that goes into this rectifier or power supply. It transforms it into something that is useful for an electronic device, and the output here is 12 volts DC, 500 milliamps. And so it transforms it from one kind of current into another that is more useful for that particular device. Now, alternating current coming into your home, very often, a lot of homes, most homes, have two different kinds of plugs or outlets. The one that we're more familiar with is this one. This is the kind of outlet you have all over your house. And these are those 120 volt, 60 hertz AC outlets. But a lot of people have a larger outlet, and these are for appliances that require a higher quantity of voltage. And these are going to be big appliances, those that require big quantities of energy. You're only going to have a couple of these around your home, very often an electric dryer, very often a stove, and possibly a welder. Those are the three in my home and in our shop that actually require the big plug. So those are going to exist, still alternate at 60 hertz, 60 cycles per second, alternating current. In order for electricity to flow in a circuit, it has to complete a complete circle. The word circuit comes from the term circle. Electricity has to move in a complete path in order for it to flow. There's got to be a source for the electricity, the charge to come out of the source, go all the way around, go through the gizmo or device that it is trying to operate, come back out, back to the power source. And it doesn't matter if it is an electrical chemical cell, if it is a power station, if it is where the electricity comes in via the power supply to your home. It has to be in that complete circle or circuit. And if you break that at any point, the electricity will stop flowing. That can be done with a switch. And we put those switches in to turn that electricity on or off. I think one of the coolest things is to understand how a simple plug works. The three prongs on a plug, one prong is for the electricity to come in. The other prong is at the other end of that circle for the electricity to flow out. And the third rounded plug on a lot of gizmos, that's your ground. That is a safety device in case there is an overload of charge that will safely take that charge to ground and help prevent a shock or danger to you and I. All right, that will do it for this time, and we'll see you later. Bye-bye.